Dear students, today we will learn about significant figures in a measurement. What do we mean by significant figures in a measurement? You remember, significant figures in a measurement are the number of digits which are reliably known plus one digit that is uncertain. So significant figures are the reliably known digits plus one uncertain digit. What do we mean by reliably known digits and what do we mean by uncertain digits? You remember, reliably known digits means the digits upon which you have the confidence, and uncertain digits means the digits upon which you do not have confidence. For example, if you are asked to measure the length of this line, if you measure it as 15.2 centimeter, upon which digits, here you see 3 digits come, upon which digits you have the confidence and upon which digits you do not have confidence. That means which digits are certain digits and which digits are uncertain digits. For this, if you ask another student to measure this, definitely he will measure 15. Then whether the third digit 1 or 2 or 3, that depends upon the instrument or the scale, measuring scale or the student. So let it be 15.3 centimeter. That means if you compare these two digits, that means upon these two digits, if you compare these two measurements, you see upon these two digits 1 and 5, you have the confidence. That means these two digits are certain digits and this digit is uncertain digit. So what is the significant figure in your measurement? In your measurement, the significant figures are these two digits, certain digits, or reliably known digits, or the digits upon which you have the confidence. That is 2, 1 and 5, plus one digit, that is uncertain digit. So number of significant figures in your measurement is 3. So you remember, more is the significant figures, higher is the accuracy of your measurement. Suppose another student measures 15 centimeter. Here in this measurement, the significant figure is 2 because it is your certain digit and it is your uncertain digit. Right? So one certain digit and one uncertain digit. 1 plus 1, that means 2 is the significant figure in this measurement. So you see, compare these two measurements, definitely it is more accurate than this. So you remember, more is the significant figures, higher is the accuracy of the measurement. Now come to rules in determining significant figures. The first one you remember, all non-zero digits are significant. For example, 2538 meter has how many significant figures? You see, all are non-zero digits and all non-zero digits are significant. Here, this measurement has 4 significant figures. The second one, all zeros in between two non-zero digits are significant. For example, 1005 meter. You see, these are the two non-zero digits. In between two non-zero digits, you have two zeros. The zeros in between two non-zero digits are significant. So it has, you see, 1, 2, 3, 4. It has 4 significant figures. Now come to the third one. The final zeros means the zeros after the last non-zero digit are significant or not. That depends upon the least count. For example, 5700 centimeter. It has how many significant figures? So that depends upon the least count. If the least count is 1 centimeter, that means you have the uncertainty at here. Then the number of significant figures 1, 2, 3, 4. These three are certain digits and it is uncertain digit. So number of significant figures is 4. Then if the least count is 10 centimeter, then your uncertainty shifts to here. These two digits are certain digits and it is the uncertain digit. Definitely it will be uncertain digit. So here when least count is 10 centimeter, 2 certain digits and 2 uncertain digits. So here the significant figure will be 2 certain digits. Here you have 2 uncertain digits, but you have to take 1 uncertain digit. That is 2 plus 1, that is 3. If the least count is 100 centimeter, you see, (5700 centimeter). Here uncertain digit is of this one, 7. That means here you have 1 certain digit and you have 3 uncertain digits, but you have to take 1 uncertain digit. So number of significant figures will be 2. So you remember, in this type of measurement, whether the final zeros are significant or not, that depends upon least count. If the least count is 1 centimeter, then significant figure is 4. That means all the zeros are significant. If the least count is 10 centimeter, then uncertainty shifts from this to this. So the significant figure will be 3. And if the least count is 100 centimeter, then significant figure is 2. Now come to the zeros after the last non-zero digit and before the decimal point are significant. So here it has, as it is the decimal point, so it has 4 significant figures. Now come to another point. The zeros after the decimal point and the last non-zero digit are significant. That means 1.200. These zeros are significant. So 1.200 centimeter has 4 significant figures. 4 significant figures. Now come to another point. The zeros after the decimal point and before the first non-zero digit are not significant. For example, 0.0012 centimeter. These zeros, the starting zeros, are not significant. So it has 2 significant figures. 2 significant figures. These are all about your rules in determining significant figures. Now come to rounding off a number. Rounding off a number. If the digit to be dropped is more than 5, then the preceding digit will be increased by 1. For example, 1.246. If the question is asked, round it up to 3 digits, means round it at here. So here the dropping digit is 6. The digit 6 is to be dropped. That is more than 5. So the preceding digit will be increased by 1. So it will be 1.25. Second one, if the digit to be dropped is less than 5, the preceding digit remains unchanged. That means if it is 1.243 and question is asked, round this number up to 3 digits, means we have to round it at here. Here the digit dropped. Digit to be dropped is 3, that is less than 5. Then the preceding digit remains unchanged. So the result is 1.24. Then if the digit to be dropped is 5 and followed by some non-zero digits, that means 1.24517. Round the number up to 3 digits. That means we have to round at here. Here the digit to be dropped is 5 and you see it is followed by another 2 non-zero digits. So then the preceding digit will be increased by 1. That means 1.25. If the digit to be dropped is 5 and followed by some non-zero digits, then the preceding digit will be increased by 1. Next, if the digit to be dropped is 5, then the preceding digit will be increased by 1 if it is odd and remains unchanged if it is even. That means 1.245. You see, if the question is asked to round this number up to 3 digits means here we have to round. That means the digit to be dropped is 5. Then you have to see the preceding digit. If it is even, then remains unchanged. If it is odd, then it will be increased by 1. You see 4 is even, so the result will be 1.24. That 4 remains unchanged. If it is 1.235, the digit to be dropped is 5. Here you see the preceding digit is 3, that is odd, that will be increased by 1. The result is 1.24 if the question is asked round this number up to 3 digits at the second decimal place. Now come to arithmetic operation with significant figures. Arithmetic operation with significant figures. In sum or difference, in sum or difference, in sum or difference, the result has the same number of decimal places as the given numbers with minimum number of decimal places. Remember, in sum or difference, the result should have the same number of decimal places as the given number with minimum number of decimal places. For example, 25.126 and 12.2. You add these two. What will be your result? 6, 2, 3, 7, 3. Here you see there are 3 decimal places and here 1 decimal place. How many decimal places will be there in the result? Here 3, here 1. We have to take 1 decimal place because we have told that the result should have same number of decimal places as the given numbers with minimum number of decimal places. That means the result should have 1 decimal place. Means we have to round this number at here. That means the result, the digit to be dropped is 2, that is less than 5. So the preceding digit remains unchanged. So the result will be 37.3. In product or quotient, in product or quotient, you remember, in product or quotient, the result should have same number of significant figures as the given numbers with minimum number of significant figures. For example, 20.5. If you multiply it by 12, here you see how many significant figures? 1, 2, 3. Here how many significant figures? 2. So the result should have 2 significant figures. Now you multiply these two. 2 5 10, 0, 1, 2 0 0, then 1, then 2 2 4. Here 5 0 2, 0 6 4 2. Here is the decimal point. So the result is 246.0. we have to round this number up to 2 digits because we have to make it two significant figures, because here it is 3, here this significant figure is 2, so the result should have two significant figures. That means we have to round this number at here to 4. That means the digit to be dropped is 6, that is more than 5. So the preceding digit will be increased by 1 to 5. You see here it is 246 and here it comes 25. There is a huge gap in the result rate. So in order to make the gap small, and another point, also the result should have two significant figures, I have to put 0 at here. So the result here 250. It has two significant figures and the answer and the multiplied value, you see the difference is also small. So the result will be 250. So you remember, in sum or difference, you have to see the number of decimal places. The result should have same number of decimal places as the given number with minimum number of decimal places. And in product or quotient, you have to see the significant figures. The result should have same number of significant figures as the given number with minimum number of significant figures.